Good morning to one and all. This is our class number 2 in this topic on camps. This topic is completely a graphical procedure of drawing various camp profiles for the required specifications given. This is the first problem what we will solve in this topic. The statement of the problem is this. All of you write down this. A cam is to give the following motion to a knife edged follower. 1. Outstroke during 60 degree of cam rotation. 2. Dwell for the next 30 degree of cam rotation. Return stroke during next 60 degree of cam rotation and dwell for the remaining 210 degree of cam rotation. The stroke of follower is 30 mm and the minimum radius of cam is 50 mm. The follower moves with uniform velocity during both the outstroke and return stroke. Draw the profile of cam when the axis of follower passes through the axis of camshaft. The cam is rotating in clockwise direction. All of you please write down the full statement of problem. If required, you pause the video and write down everything properly in your notebook. Read the problem thoroughly. First understand all the specifications, whatever are given in the problem, and then only you play the further part of the video and do the drawing with all the drawing instruments along with me and complete the drawing of cam profile. Then only you will learn how to draw the cam profile. Otherwise, only by listening to the video you will not learn how to draw the profile, or maybe while drawing the profile you may face difficulties. So my advice is, whenever you are doing the drawing, understand some part, pause the video there, complete the drawing up to that point, then play the video for some more part, do that much drawing, again start the video, and continuously along with the video you do the drawing as it is explained. Then you will have better understanding. In this problem, first you understand the follower is a knife edged follower, very basic type. Then the follower is moving up for the first 60 degrees of cam rotation. Then it is remaining at the lifted position for the next 30 degrees. Here the minimum radius of cam is 50 mm, base circle radius is 50 mm, and the follower stroke, that is the maximum lift the follower is getting lifted for is 30 mm, and for the first 60 degrees it will get lifted from 50 mm to the maximum height of 30 mm, and for the next 30 degree dwell means it will remain at the lifted position. It will neither go further up or nor it will come down also. At the lifted position by 30 mm it will remain there only. Then for the next 60 degrees it will gradually come down from the lifted position of 30 mm to original base circle radius of 50 mm, and remaining 210 degrees it will remain there at the minimum radius of cam, what is 50 mm. If you add all these angles, 60 plus 30 is 90, plus 60 is 150, plus 210 is 360 degrees, full circle of the cam. That is what it is. First, before drawing the cam profile, we will draw this diagram, what is called as a displacement diagram. This displacement diagram will give us at what angle of rotation of cam the follower will be at which position, will be at what height from the center of cam. So for this, along x-axis we take the angle of rotation of cam. So along this x-axis you can see we have taken 60 degrees for the rise, 30 degree for the dwell, like that, 60 degree for the return stroke and 210 degree for the dwell. So along x-axis we have taken the angle of rotation of cam, and along y-axis we have taken the lift of the follower. So in y-axis, along y-axis you measure this height as 30 mm, 3 centimeters, and draw this second horizontal line. So these two horizontal lines are apart by distance of 30 mm. Now along x-axis you have to make these divisions. This first 60 degree you can either take 6 centimeters or 3 centimeter, or you can take 12 centimeter, or any distance you can take. But if you take this as 6 centimeters, then this will be 3 centimeter, this will be again 6 centimeter, this will be some more. So this x-axis will be bit longer and you may not be able to fit it in your book. So for this problem you do as I am doing. For the further subsequent problems you will get your own idea how much length you should take and how to fit exactly in your book. So this first rise of the follower, that is outstroke, is for 60 degrees. So you measure 3 centimeters here, 3 centimeters, and draw this vertical line. So when this is 3 centimeter, 30 degrees, 1.5 centimeter. Measure that, draw this second vertical line. Again 60 degrees, 3 centimeters. Measure here, again draw this vertical line. And now the lift of follower is not important hereafter. So you take some convenient distance. Even if you take this much, it is fine. Even if you take bit more also, it is fine. So take some convenient distance and draw a zigzag line and complete this rectangle like this. So along x-axis we have taken the angle, and along y-axis we have taken the lift of follower. So the initial 60 degrees is outstroke, next 30 degrees is dwell, then next 60 degrees is return stroke, and remaining is again dwell. What we will do now is we will divide this 60 degrees, we have divided here into 6 equal parts. So we will divide into some even number of equal parts. You can divide into 8, 12, minimum 6 you have to do. I have done here 6 divisions. Since it is 3 centimeter here, every division is half centimeter, that is 5 millimeter. Half centimeter here, 1 centimeter or 10 millimeter, 1.5 centimeter, 2 centimeter, 2.5 centimeter, and 3 centimeter. Similarly here also you do 6 divisions, 5 mm, 10 mm, 15 mm, same, 1.5 centimeter, 2 centimeter, 2.5 centimeter, and 3 centimeter. Make equal 6 divisions. Now all these divisions will mark starting from 0, 1, 2, 3, 4, 5 and 6. Similarly these divisions we will mark as 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. Now from every division I will draw one vertical line till the top line. So from every division I have drawn vertical lines from till the top line. Now I will draw the displacement diagram for the follower motion of uniform velocity. When the follower is moving with uniform velocity, what we do is, for the outstroke, this corner we will join with this corner of the rectangle, and this will be the displacement diagram. Similarly for the return stroke, this corner of the rectangle will join to the this corner. So this is a displacement diagram. So drawing displacement diagram for uniform velocity, displacement curve of the follower is very simple. So you have to just join these corners of the rectangle and you will get the displacement diagram. Now you see this point, starting point I have marked as A. This point where this curve has intersected the first vertical line I have marked as B. Wherever the curve has intersected the second vertical line I have marked as C. Wherever this curve has intersected third vertical line I have marked as D. This is E, F, G, H here, J, K, L, M, N and P. I and O are not marked because those may confuse with 0 and 1. So I have not marked with them. So this is the displacement diagram, and with this displacement diagram we will draw the cam profile. So wherever you draw the cam profile, above that here or bit more above this, you have the displacement diagram drawn, so that all the distances you can very easily measure from the displacement diagram and mark them on the cam profile and complete the cam profile. So you should have the displacement diagram above the cam profile whatever you are drawing. So first in this cam profile, by taking this as center, I have drawn the base circle of cam which is having the radius of 50 mm. So first you draw this circle having 50 mm radius, and now for this problem I will tell you our profile is coming something like this. So you please leave some space this side, that is to the left you have some space, and also some space here above. Even if you don't have any space on the right hand side and below this, it is fine. Here and here it is fine, but please see that you have some space here and some space above. So draw this circle exactly at the extreme right end of your page. The placement of displacement diagram and cam profile need not come like this. This may come above here or to the left, and then the cam profile can be there. So leave some space on your page here and above and draw this circle to the extreme. Even if your page is like this, it is, even if your page is like this, it is fine. So first what we will do is, we will from here for the outstroke we will measure the 60 degree from this vertical line. Before that we have drawn this knife edge follower. How we have drawn that is, just from this draw a vertical line passing through the center of this circle and draw two lines like this, and then draw this knife edge follower. Even if you draw a bit more height of follower, it is fine. Even if you draw it bit short, there is no exact dimension for the follower height what is given, so you need not worry about that. Even if you can draw it like this here, a bit here, and even if you complete the drawing like this, it is fine. So draw this follower and complete this. Next, from this vertical line for outstroke, since it is for 60 degree, you keep your protractor here and draw a line at 60 degrees for outstroke. So this is outstroke. Then from this line again you measure 30 degrees, this is for dwell, and again from here you measure 60 degrees, this is for the return stroke. So these three angles are important. The remaining 210 degrees is not important for us. Next, what you have to do is keep your again protractor here and divide this 60 degree into 6 equal parts. So mark 10 degree, 10, 10, 10, 10, 10. Mark 10 degrees here. Every first from here you measure 10 degrees, mark a point, 10 degrees, mark a point, 10 degrees, mark a point, and passing through center you draw all these lines 1, 2, 3 for every 10 degrees. So these lines, even if you draw these lines a bit longer also, it is fine. These lines also, if you draw a bit longer also, it is fine. All are thin lines, you can draw to any length, it is fine. So this is a dual. The cam, the follower will remain, will not do any divisions here, as we have not done here also. And then the last return stroke 60 degree, whatever is there, there also we will make 6 divisions. So you keep your protractor here, from there you measure 10 degrees, mark a point, 10 degrees, mark a point, 10 degrees, mark a point, and passing from center you draw lines through all those points and get 6 lines like this. Even if you draw those lines bit longer, it is fine, nothing will happen. Don't rub those lines, draw them thin lines. Next, at the base circle, this is our base circle. This is our base circle. Now, this is point, we'll mark this point as 0, this as 1, this as 2, this as 3, 4, 5, 6, 0 dash here, 1 dash here, 2 dash here, 3 dash here, this is 3 dash, this is 4 dash, this is 5 dash, and this is 6 dash. We have marked the same points as they are here on this displacement diagram. If you have done 8 divisions in this, again you have to make 8 divisions here, 60 divided by 8, and then mark the points accordingly. Now what we will do to this is, now 0 and A are at the same point, 0 and A are at the same point. Now to mark B, what we'll do is, with the rounder you measure the distance 1 to B. Don't measure with scale, take your rounder and measure 1 to B. Keep your rounder at 1 and draw an arc like this. Wherever it will intersect the line, the point B will be there, this intersection. Similarly, 2 to C you measure with your rounder and keep it here and draw an arc on this second line, this is point C. Similarly, 3 to D you measure, 3 to D you measure, 4 to E you measure, keep on 3, draw the arc, keep on 4, draw the arc, and get the points D and E, like this, D and E. Similarly, from 5 to F you measure, draw the arc, 6 to G you measure, draw the arc, and mark all those points. Similarly, 0 dash to H you measure, and 0 dash you keep the rounder, draw this arc. Similarly, 1 dash to J, 1 dash this length exactly you measure with rounder, 1 dash to J, and keep your rounder at 1 dash, draw the arc J. So similarly we will get the arcs 1 dash J, 2 dash K, 3 dash L, and then 4 dash M you measure, then keep on 4 dash and draw M, and here N, and will come to point P. So we have done all these points, and these all points we have marked to draw the cam profile. Now our actual cam profile is a smooth curve what is passing through all these points. That is, it will start from A and next B, C, D, E, F, G, like this we will draw a smooth curve. So we have started at A to B to C, D, E and F. And one important thing to remember here, in this problem it is given that the cam is rotating in the clockwise direction. The cam is rotating in the clockwise direction. So we have drawn the profile in the anti-clockwise direction. This point you very clearly understand. So we will draw the profile in the opposite direction of cam rotation. So we have drawn it in the anti-clockwise direction. You have to do like this. If the cam is rotating in the anti-clockwise direction, then you have to do all this construction on the other side. Then your curve will come like this, exact mirror image of this. So because this cam is rotating in the clockwise direction, this cam profile we have drawn in the anti-clockwise direction as it is shown here. Now similarly, the curve further you extend to the points G, H, J, K, L, M, N and P and complete the curve here, and that will become your full cam profile for this specific problem. So this is the full cam profile what we have obtained. So to summarize, you please understand, if the cam is rotating in the clockwise direction, we will draw the profile in the anti-clockwise direction. Will make divisions on the base circle, as many divisions we have drawn in the displacement diagram for the angle, and we get the cam profile like this. We'll end the lecture here. Thank you.